Hello and welcome to the Introduction to Graph-Based Modeling using Python. My name is Chris Wagner and I'm going to be taking you guys through this. Okay, so first, what are graphs? Well, a graph is a data structure that consists of two components, nodes or vertices, and edges or links. For example, brain networks, chemical compounds, social networks, transportation networks, etc. can all be modeled using graphs. So what are the components of graphs? First, we have nodes, which are the fundamental units that represent entities. And then we have edges, which are the connections between nodes that represent some relationship between entities. And there are many types of graphs. One is an unweighted graph, where all edges are weighted equally. Another is a weighted graph, which each edge has a weight, which represents the strength of the cost of a connection. We have an undirected graph, in which edges have no direction, and a directed graph in which edges do have a direction. So let's take a look at an undirected graph here on top, and then a directed graph on the bottom. As you can see here, this edge models the flow of information between two nodes, and we can see that information flows back and forth between this node and this one. Similarly, this node and this node has a connection such that this edge models information flow only from this node to this one. Now let's take a look at an example. So we can model a transportation network as a graph where the nodes are the roads and the edges are the intersections. And so here on the left we have a road segment, and then we have the resulting graph on the right. And this is useful for several things, including efficient route planning via shortest paths, traffic flow simulation, and emergency response assessment, as well as urban planning and development. And so now let's take a look at Python example. Okay, so we've installed the libraries and we've loaded the data. And so now let's visualize it. So here's the San Francisco road network, and now we can calculate some summary statistics. And so this will show us some information such as the average road length, the average number of streets per road, etc. And then we can find the shortest path between two given locations. So we're going to be looking at San Francisco City Hall and the Golden Gate Bridge. And so let's find that and then also visualize it. So here is the shortest path. And this is something that's likely going to be coming up if you were to put this into a GPS. And so this is the route that you would likely take. All right, now let's simulate some traffic flow. So we're going to first define this function, which allows us to traverse through the graph. And then we're going to print out the graph at each time step. And so these red dots represent the different cars and their position. And so this is essentially tracking movement throughout the network. Now let's take a look at the final position of each vehicle. So this is it right here. Here's the position of the final vehicles. And now we can do some analysis. So we can count the vehicles at each node, and we can also count the bottlenecks, identify the potential bottlenecks, And so we can also print this and show where exactly the bottlenecks of traffic are. And here we go. Thank you guys for watching. I hope you guys found this useful, and it will be linked in the description of this video in case you want to run this code yourself. Thank you.